Hello! Today we are going to be talking about matching functions to their derivatives when we are given graphs to look at. These types of problems are almost always about matching characteristics from function to its derivative or vice versa. You might be wondering, which characteristics should I be looking at? Well, there is specific relationship between derivative and its function. If the function increases, then the derivative is positive. Same thing for the other way around. If we know that the derivative is positive, then we know that the function must be increasing. We can make very similar statement about decreasing when derivative is negative. Now, if we know where function increases and decreases and where it should start and stop doing one type of thing, then we can figure out where our derivative is equal to 0 and where it has a sign change and what kind. If function goes from increasing to decreasing, then we have maximum, and this means that our derivative goes from positive to negative. If the function goes from decreasing into increasing, then this means we have minimum value, which means that our derivative goes from negative to positive. This is usually the type of thing that we will be looking at when we are trying to eliminate wrong answers. This last bullet point is something you might call bookkeeping. It is something that we need to consider, but not necessarily something that needs to be in the front of our mind. According to extreme value theorem, we always have to check endpoints as maxes and mins anytime our function is defined on a closed interval. No matter the type of interval your function is defined on, anytime your function has max or min value, this implies that your derivative must equal 0 and, more importantly, changes sign. This does not work both ways. If the derivative equals 0 and this is all you know, all you can say is that the function has a horizontal tangent. You will need to know about the signs and if it changes to determine if you have max or min. Let's go ahead and take a look at two examples here to see how this works. First example gives us graph of derivative, and we are supposed to pick which graph of the four could be the original function. So we are going to look at sign changes to determine maxes and mins. Positive to negative in derivative means original function has max. Negative to positive in derivative means original function has min. And over here again, positive to negative means we have max. With this information, we can start to get rid of wrong answers. We see here in answer choice A, we don't have min at x equals 0. This means A is wrong. In answer choice B, yes, we have min here, but you see how this goes up so fast over here on the right? This is a little too steep according to our derivative here. Look up here. You see how the movement is nice and smooth and periodic? This, no, not something that we see here in B, so we cross that out. In C over here, we have min at 0, and then we have max to the left, max to the right, smooth movement. This one seems to fit the bill. So we will check D just to make sure, and again, no min at 0, so D is wrong. This means we have eliminated all answers except for C, so we have final answer here. So you see the skill is just matching. Analyze the graph that you're given, and then eliminate all the graphs that don't have the expected characteristics. Next example, we're given original function and we have to match derivative. So this time we will look at the maxes and mins of this to figure out sign change in derivative. Min means we go from negative to positive in the derivative. Max, like over here, means we go from positive to negative in derivative. And over on right side we have one more min, which means we expect negative to positive change on the right side. Two changes on the left, one on the right. Let's take a look at our answer choices. We see here that we only have one sign change on the left, and it's not even the correct kind, so we cross that out. And then we move on to next thing. In answer choice B, we have two changes on the left, one on the right. They are in the correct order, negative to positive, positive to negative, negative to positive. This one checks out, but we still need to check our other answers. This right here is graph of tangent. Makes no sense in this situation, so we can just cross that out. Looking at last possibility, we see we don't even have any changes on the left-hand side, so that crosses out. And once again, we have gotten rid of 3 out of the 4 answers. B is the only one that makes sense here. Yes, again, matching game. If you are given graph of derivative to start, then you are going to look where that graph changes signs, because those sign changes are going to indicate where you can expect extreme values on original function and what kind of extreme values those are going to be. If you have graph of original function to start, then you are going to look at those extreme values because that is going to tell you what kind of sign changes you can expect in the graph of your derivative. If you decide to make analysis too challenging, then you will make the rest of the problem too challenging as well. Just look for broad characteristics. As you saw, we did not do too much thinking here. It was just where did we increase, where did we decrease, and when did our derivative change its sign. This is all I must say to you. Goodbye.